this video we're going to take a look at normal distributions, and we're going to take a look at finding probabilities using normals and approximation of the binomial. Let's take a look at our flow chart. This is finding probabilities. Now remember, there's other names for probabilities. There's find percentage, proportion, or area. So any of those words mean the same thing in terms of this function. Now our first type is where it says standard normal distribution. We looked at it in a separate video. Our second type is we're looking at one item. So find a probability that a person has an age greater than 50. Then we have another type, which is many items. Find that the 30 people have an average age greater than 50. So we're talking about many people, many books, many cars, whatever we're looking at. This is also called the central limit theorem. And then the one we're going to be looking at in this video is a normal's approximation of the binomial. You'll actually see those words, or they'll refer to an approximation. It's a binomial setup. Now our form of our function in this video will be normal d underscore CDF, and then we'll have our mean, which for a binomial is n times p, comma, and then our standard deviation, which is the square root of n times p times 1 minus p, comma, and then our x. And this x here is with a correction factor. Now I'm going to look at 6 different examples in this video because it's a little bit harder, and it's mainly the correction factor that's kind of the difficult part. Okay, for purposes of our example, we'll assume n is 105 and p is 0.2. This is our number of trials. Maybe we got a weird dice. It's not our standard dice, and we're going to roll it 105 times, and the probability of whatever we're studying is 20%, 0.2. So our first example, we'll look at the probability. And again, whatever we're studying, we're going to get x is less than 23. So less than 23 of them. Well, let's draw our picture. Here's 23. And less than is going to be shaded to the left. What you have to ask yourself for the correction factor is we're going to either subtract 0.5 or add 0.5. But you have to ask yourself if this wording here, and I know I just wrote the symbols, but if this wording here includes 23 or doesn't. If this includes 23, our shading has to include 23. If this does not include 23, our shading cannot include 23. Well, x is less than 23, it doesn't include 23. So I'm going to subtract 0.5. And then I'm shading this way. Again, wording does not include 23, your shading cannot include 23. If I had added 0.5, it would have included it. Well, this is already based upon the area to the left, so we're ready to plug in our calculator. Now, no matter where you are on HP prime, whether you're in this menu, whether in one of these functions, you just press your home. And then I'm going to press my toolbox here. And you have 3 options down here: math, CAS, and app, or you may have other ones depending upon what you're in. But you want math chose. Okay. Now we want to choose probability, so choose 5. I want to choose 6 for cumulative. Choose 1 for normal. And we're going to put in n times p. Well, we got 105 times 0.2 n times p. And then comma. And then we want a square root, so we'll do our shift x squared. And then we want n, which was 105, times p, which is 0.2, times, and then I'll put a parentheses here, and then I'll do 1 minus 0.2. You could also simply just put 0.8 there. If that's 20%, then this has got to be 80%. Now notice where my cursor is. I'm going to do a right arrow to get it out of that parentheses. I'll do another right arrow to get it out of the square root. And now we're ready for our last parameter. So comma, And then we want our corrected x, which is the 22.5. And then I'll press enter. And I'll round it to 4 decimal places. 0.6428. So 0.6428. Okay, let's look at our second example. Probability that x is less than or equal to 25. Let's draw our picture. Here's 25, and I'm going to either add 0.5 or subtract 0.5. Actually, I got more than 6 examples now I'm thinking about it. So on this particular one, we have to look over here at our wording, see if it includes 25, and it does, because this says x is less than or equal to 25. So I'm going to add 0.5. Because less than is shaded to the left. If your wording includes 25, then your shading has to include 25. Always use that as your guideline on how to do the correction. So now we're ready to plug it in. Our HP prime is requiring us to do the area to the left. So I'm going to come here and do my toolbox. Choose 5 for probability. Choose 6 for cumulative. Choose normal. Put in my mean, which is n times p. So I got 105 times 0.2, comma, then the square root. So I do my shift x squared, and then n, which is 105 times 0.2, which is our p, times, and then I push my parentheses, and then 1 minus p. So 1 minus 0.2. Right arrow to get it out of the parentheses, right arrow to get out of the square root, and then I'll do a comma. And then the corrected x, which is 25.5. And then press enter. And then we got 0.8639. So 0.8639. Okay, now let's look at our greater than case. So let's look at the probability that x is greater than 24. Okay, so here's 24. So we have to ask ourselves if our wording includes 24. X is greater than 24, so it doesn't include it. So that means I'm going to add 0.5. So this is what we're trying to find right here. Again, if your wording doesn't include 24, your shading should not include 24. If we had subtracted 0.5, our shading would have included it. Well, with the HP prime, it does not handle the area to the right. We're looking for the area to the left. So we're going to need to rewrite this as 1 minus, and then I'm working with a corrected value, so 24.5, and the area to the left. And it's always of this form. Whenever it's shaded to the right here, you always rewrite as 1 minus, and then the area to the left shaded of that same value. And if you think about it, 1 is the entire normal distribution. So if we subtract off the area to the left of 24.5, that'll leave us the area to the right. And now we're ready to plug that into our HP prime. So I'm going to do my 1 minus, and then I'll choose my toolbox. 5 for probability, 6 for cumulative, 1 for normal. We've got our mean, which is n times p. So 105 times 0.2, comma, square root. So we do shift x squared. N, which is 105, times p, which is 0.2, times, and I'll put it inside of parentheses, 1 minus p. So 1 minus 0.2. Right arrow to get it out of the parentheses, right arrow to get it out of the square root, and then I'll do a comma, and then I corrected x value, which is 24.5. And then I'll press enter. I made these numbers up. I'm surprised I haven't come up with any real bizarre values yet, but we'll see. 0.1966. 0.1966. Rounded to 4 decimal places. Okay, let's look at our greater than or equal to case. So we got x is greater than or equal to, and let's say 22. Okay, well, let's see what we got with our correction factor. Here's 22. And we're going to either subtract 0.5 or add 0.5. It's always 0.5. We have to ask ourselves if this includes 22, which it does. X is greater than or equal to 22. So we're going to subtract 0.5. Because greater than is shaded to the right. And again, if our wording here includes 22, our shading should include 22. So if it doesn't, that means you did the wrong one, and you should have added 0.5. Okay, again, our HP prime is based upon the area of the left, so that doesn't work well. So we're going to do 1 minus, and then take my corrected x, which is 21.5, and then shade to the left. It's always this way. If you're trying to find the area to the right like this, you do 1 minus, and then the area to the left of that same x value. Well, now we're ready to plug that in our calculator. Okay. And you can actually, there's shorter ways than just retyping it each time. You can use your up arrow to go up here, but I'm going to do it each time just so we clearly see where it is, even though it seems redundant. Okay, so I'll do 1 minus, and then I'll choose my toolbox, and then choose 5 for probability, choose 6 for cumulative, and 1 for normal. And then n times p, so I got 105 times 0.2, comma, square root, so I'll do my shift, x squared, n, which is 105, times p, which is 0.2, times, and then I'll choose my parentheses here, and then 1 minus p, so 1 minus 0.2. Right arrow to get it out of the parentheses, right arrow to get out of the square root, and then I'll do a comma, and then we want to put in our corrected x value, which is 21.5. And then we'll press enter. And we get 0.4515. 0.4515. I double check that. It's kind of early in the morning. Yeah, it looks right. Okay, while I'm here, let me go ahead and do the equals case. So I'll do x equals 22. Well, on the equals case, we're looking at exactly 22 here. So what you have to do, correction factor, is you have to add and subtract 0.5. So we'll have 21.5 to 22.5. Now it's the same idea. If this includes 22, our shading has to include 22, and we're always looking from one value to another value on the calculator. So this is what our setup is. Now when you got between two values, the HP prime is only based upon the area to the left, and it's shaded clear to the left. So this isn't in the right form. So we're going to rewrite this. Picture-wise, we start with our largest corrected x value, which is 22.5, shaded to the left, minus, and then we take our smallest one, which is 21.5, shaded to the left. Always of that same form. Largest one goes first, smallest one goes here, and it's that. Because if you think about it, if I look at the area to the left of 22.5, if I subtract off the area to the left of 21.5, that'll give me the area in the middle. So that's how we're going to plug it in. Okay, so I'm going to choose my toolbox here, choose 5 for probability, I'll choose 6 for cumulative, choose 1 for normal, and I got n times p, so I got 105 times 0.2, comma, and then square root, so we do shift x squared, n, which was 105, times p, which is 0.2, times, and then I'll do the parentheses, 1 minus p, so 1 minus 0.2. Okay. Get it out of the parentheses, right arrow once, right arrow one more time to get it out of the square root, and then comma, and then our corrected x value, which is 22.5. Now I'm going to do my right arrow to get it out of the parentheses, and then I'll do my minus. That's this right here. And now we're going to do the picture on the right. So I'm going to choose my toolbox again, choose 5 for probability, choose 6 for cumulative, choose 1 for normal, n times p, so I got 105 times 0.2, comma, and then square root, so shift x squared, and then we'll put n, which is 105, times p, which is 0.2, times, and then parentheses, 1 minus p, so 1 minus 0.2, right arrow, get out of the parentheses, right arrow, get out of the square root, comma, and then our corrected x value, which is 21.5. And then press enter. And we get 0.0943. Let me double check that. Kind of got a there. A little bit of headache. So, okay. Take a look at our next example. This is going to be the between cases, and I'll do 2 examples, and after that you'll pretty well understand how to do the different ones. This definitely doesn't include all the between cases. Okay, so we got 20 to 23. Here's 20, and here's 23. Now for each one of these values, you're going to either add or subtract 0.5. And again, it goes back to, does this wording up here include that number? For example, this right here does not include 20. So our shading could not include 20. So I'm going to add 0.5. So I'll have 20.5. This does not include 23. So our shading cannot include 23. So I'll subtract. So I have 22.5. And then we're shading in between them. It's real easy if you follow that concept. If wording does not include that number, your shading should not include it. So our wording doesn't include 20, and you notice our shading does not include it. Our wording does not include 23, so our shading does not include 23. And now we're ready to actually do our picture. When you got the between case, then you rewrite this. You take your largest corrected x value, which is 22.5, and the area left, minus your smallest corrected x value, which is 20.5, the area left. And that's how we'll plug it in the calculator. And let me do this first one here. So I'm going to go into my toolbox. I choose 5 for probability, 6 for cumulative, choose 1 for normal, n times p, so we got 105 times 0.2, comma, square root, so shift x squared, n, which is 105, times p, so times 0.2, times, and I'll do my parentheses, and 1 minus p, so 1 minus 0.2. And I'll do a right arrow key to get out of the parentheses, right arrow key to get out of the square root, and I'll do comma, and then my corrected x value, which is 22.5. Okay, then I'm going to right arrow to get it out of the parentheses, and I'll do my minus. That's this right here. And let's do this one. So do my toolbox, choose 5 for probability, choose 6 for cumulative, and choose 1 for normal. And then I'll put n times p, so I got 105 times 0.2, comma, Square root, so we do shift x squared in, which is 105, times p, which is 0.2, times, and then my parentheses, 1 minus p. So 1 minus 0.2. Okay, so now I'm going to do a right arrow to get it out of the parentheses, right arrow, get out of the square root, do a comma, and then I'll put in this corrected x value, which is 20.5. And then press enter. And we get 0.1913. 0.1913. Okay. One last one of those. Say we got the probability that we got 21 is less than or equal to x is less than 26. Okay, so if I drew the picture, here's 21 and here's 26. Now I want it to include 21, so I'm going to subtract 0.5 there. On the 26, it does not include 26, so I'll subtract. So this will be 25.5. Okay, so I'm shading in between the corrected x values, like that. And now let's talk about adding and subtracting 0.5. Up here it includes 21, and you notice that our shading includes 21. So that part worked, that correction factor. Over up here it does not include 26 because there's no line underneath. So, and you notice down here, our shading does not include 26. So we did it right. Well, again, when you get your between case, you're going to rewrite it in this form. You take your largest corrected x value, which is 25.5, shade to the left, minus your smallest corrected x value, which is 20.5, shade to the left. And that's how we're going to plug it in. And I'm definitely not an expert at HP prime, but you know, if there is some way to do between values, I haven't found it, but this way does work. So I'm going to do the first one. So I do my toolbox. I choose 5. Choose cumulative. I choose 1 for normal. And n times p. So I got 105 times 0.2, comma, and then the square root. So we'll do shift x squared, n, which is 105, times p, which is 0.2, times, and then inside of parentheses, 1 minus p. So 1 minus 0.2. Right arrow get out of the parentheses, right arrow get out of square root, and then I'll do my comma, and then my corrected x value, which is 25.5. Then I'll do a right arrow key to get out of the parentheses. And I'll do minus, and choose my normal d underscore CDF function again. So do my toolbox, choose 5 for probability, choose 6 for cumulative, choose 1 for normal, n times p, so I got 105 times 0.2, comma, square root, so we'll do shift x squared, n, which is 105, times p, which is 0.2, times, and then inside of parentheses, 1 minus p, so 1 minus 0.2. Do a right arrow key to get out of the parentheses, right arrow get out of square root, then comma, and I'll put in this corrected x value, which is 20.5. And assuming I typed everything in correctly, press enter and see what we get. 0.4124. Okay, now, like I said, there's different possibilities. I put a line underneath here, less than or equal to. We put a line underneath here and no line under here. So there's different cases, but I think those two examples will show you exactly how to work with that. Now in this video, we took a look at finding the probabilities for the normals approximation of the binomial on HP prime.